Good morning, everyone, and welcome to this lecture. We are in Newton laws of motion, and in today's class, we are going to finish it. I think in the last class, we had done questions on the mass of the string. Do we remember it? Yes or no? Okay. Just to get you in tune, I'll give you one more question. So do it fast so that we can move ahead. So I'll get you a question. This is a block of let us say 6 kg, and it is attached to a rope of 2 kg. Now this entire thing is going down with an acceleration of 2 meter per second square. You have to find out the tension at this point A, the upper part of the rope, and tension at this point B, which is the lower point of the rope. We understand this question? Yes or no? Tension at the upper end, tension at the lower end. Acceleration is given to you. I will give you 2 minutes to do this. Yes, anyone has the answer? You're still trying. Okay, I'll give you 2 minutes. Got the answer, everyone? No one got the answer? No one got the answer? Okay, so how are we supposed to do this? We know the acceleration. How do you find out the tension at point A, the upper point, and tension at the point B, the lower point? We have done the same question here. This was the same question. This was the same question. The only difference between this question and the previous one is this was going up, this is going down. In this question, I had given you the force. I'd asked you the acceleration. In the next question, I've given you the acceleration. I've asked you the force. There's no difference. It's the same thing. Anyways, how do I get the tension at point A? To get the tension at point A, what do? I take this one and this entire thing as one block. Block. Then if I draw the free body diagram of this block, the entire thing, the weight is downwards. How much is the weight? 2 plus 6, 8. 80 newtons is downwards. Do we understand this? Then the tension in the string, tension at point A is upwards. Tension is upwards. Weight is downwards. And this is moving downwards. So what will be the equation? Do you have a mic that can talk? No one? Have you forgotten what we had done in the last class? Tension is upwards, weight is downwards, acceleration is downwards. You cannot make the equation? Okay, the equation would be 80 downward force minus T upward force is equal to total mass 8 into A. A is 2. So I get 80 minus 16 equal to T, or T becomes 64 newtons. 64 newtons is your answer for the first part. Tension at point A is 64 newtons. Now, how do I get the tension at point B? To get the tension at point B, I only take this block, this 6 kg block. If I draw the free body diagram of this 6 kg block, tension at point B is upwards. The only force is 60 newtons. The weight of this block, which is downwards, this is moving down. The acceleration is 2 meter per second square. Can you now tell me the equation for this one? No one knows this? Okay. This is upwards, this is downwards, and this is downwards. So what is the equation? Downward, acceleration is downwards, so downwards minus upwards is equal to M into A. So from there you can get tension of the block, tension at point B, 60 minus 12, that is 48 newtons. So these are your two answers. Tension at point A is 64 newtons. Tension at point B is 48 newtons. What was so tough here in this question? Do we understand this? Yes or no? I'll give you 1 minute. Note it down, and I'll give you one more question. There's no point if you can't do the question in the examination hall. There's no point of me going ahead. So I'll have to give you one more so that I am sure that you will be able to do it in the examination hall. Everyone has noted this down? Okay. Give you 1 minute. Let me know once you are done. Done, everyone? Done? Okay, then. Here is the question for you. There is a rope of mass 2 kg and a block of mass 8 kg. The system, it is moved up with an acceleration 3 meter per second square. You need to tell me tension at the highest point, the force at the highest point, and force at the lowest point of the string. You will get 2 minutes to solve this. Please do it. Have you noted down, bacha? Have you done the question? Shall we move? Everyone got the answer? Yes or no? You want more time? Shall I do it? Say something so that I understand what is happening. Don't tell me anything I will not understand. Okay, so how are we supposed to do this? To find the tension at point A, I will take this entire thing as one body. If I take this entire thing as one body, the upward force, pulling force is tension at point A. The downward force is the weight of this entire body. What is the weight of this entire body? 8 plus 2, 10 kg multiplied by G. So it becomes 100 newtons. Acceleration is upwards. Tension is upwards. 100 is downwards. What will be the equation of this block?
T minus 100 is equals to 10A.
TA, tension at point A, minus 100 is equal to 10 into A is 30, A is 3. So what is the value of tension at point A? 130 newtons. Do we get this? Then to get the tension at point B, I will just take this block, 8 kg. I draw the free body diagram. This is tension at point B. This is 80 newtons. This is moving upwards with an acceleration of 3 meter per second square. Can anyone tell me the equation of this block?
TB minus 80 is equals to 80.
TB minus 80 is equal to 8A. A is 3. That is the answer. So tension at point B
104 newtons.
104 newtons. Absolutely correct. Everyone understood this? Yes or no? Great. So that finishes our this part of this chapter where we had dealt with what? We had dealt with motion of a body attached to a string which has a mass. We'll move on to the next part. Everyone understand this? Shall we move on? The next part is what I see a lot of questions coming from is your spring balance. Spring balance. This is the part where you get most of the question. Now remember, how does a spring balance or a question on spring balance look like? It just has a spring, nothing else. The spring balance is nothing, but it only has a spring attached and you have a balance. So this is how the spring balance looks like. On your right hand side, you can see a spring balance. You hang something by it and it tells you something. What does a spring balance do? What does a spring balance do? Now, we might think that the spring balance tells the weight of the body. It actually does not tell the weight of it does not tell the weight of the body. It measures the force exerted by the weight. So it measures the force exerted by whatever is hanging. It measures the force exerted by the body. Whatever body is hanging, it measures that force. Remember, it does not measure the weight of the body. It actually measures the force. But if you draw the free body diagram, if you draw the free body diagram of this block, bacha, you will see that this weight mg is downwards and this tension T is upwards. Now this block is in equilibrium. Do we understand this? Yes or no? The block is in equilibrium, so this tension is equal to the weight mg. What will this spring balance measure? It does not measure the weight, it measures this value of T. So this T is the value that this spring balance reads. So the reading of the spring balance will be the tension T. Do we understand this? That is what a spring balance measures. It does not measure the weight directly. It actually measures your force exerted by the block on the spring balance, and therefore you get the value of the weight not directly but indirectly. We understand this? Yes or no? Okay, do it fatafat so that I can move on to some questions here. Spring balance. You can expect questions on spring balance. Have we noted it down, bacha? Then comes this question. This is a very famous question. It has come in many exams many times. You have two spring balance, number one and number two. It will be given that both the spring balance are light. Whenever they use the word light, that means they are massless. Ideal, we call them. Then you have a block, this green block, which is attached to the lower spring balance. The mass of that spring, that block would be given. In this case, it is 20 kgs. And then they ask you what is the reading in the spring balance. What is the reading in spring balance 1? What is the reading in the spring balance 2? So that is what I'm asking. Readings. What are the readings of the spring balance 1 and 2? And you have 1 minute to give me the answer. Do we have any answers here? What is the readings? What is the reading of the spring balance, my dear friends? Anyone? Anyone can give me the answer? What is the reading of the spring balance? No one can give me the answer. No one knows what is the reading. Okay, that is unexpected. I thought that you would know this. No one knows? Say yes or no so that I'll move ahead. No one knows? Okay, then the answer is this one. The reading of the spring balance 2 would be 200 newtons. And the reading of the spring balance 1 would also be 200 newtons. If I draw the free body diagram of this block, this is 200 newtons. The tension T would be 200 newtons. This tension would be the reading of this block, which is 200 newtons. The spring balance is massless, so whatever reading this has, this will also have the same reading because the mass is not there. So reading of both the spring balances are 200 newtons each. That is the answer. I don't know what was so tough in this. Why were you not able to solve this? Tell me. Many reason that you could not solve? Tell me the reason. No reason. Okay, no reason is a good reason. We'll move ahead. The next question. Note this down. Please say something. If you don't understand, say. If you don't say anything, that will not serve any purpose. Remember, those who remain quiet, a crime is happening somewhere. One person is committing crime. One person is facing that crime. Both are criminals. The person who is committing a crime is a criminal. The person on which crime is happening is also criminal because he is letting the crime to happen. The people who are watching, they are also criminals because they don't say anything. So if you don't say anything, you are a criminal. Anyways, that was my definition of a criminal, and that comes the next question. You have to find out the reading of the spring balance. This is the spring balance, and you have to find out the reading of the spring balance. The spring balance is attached to a pulley, and two forces F and F are acting on the pulley. What is the reading of this spring balance? Do not waste your time in drawing the diagram. Waste your time in understanding the question and answering it. No, do not waste the diagram in the. Do not waste your time in drawing the question in the very way that it is drawn. Just draw a rough diagram and give the answer. That is more important rather than writing the question. The only thing that I see you doing is writing the question and then sitting and looking here and there. I've written the question, now what to do? You should spend minimum time in writing the question. Should not even write the question. Just draw the diagram. Write the question in short, 1 minute, half minute, and then spend your time in solving it. Yes, what is the reading of the spring balance? I'll give you 1 minute. I need an answer. Yes, what is the answer, beta? What is the reading of the spring balance? If you don't know the answer, say no. If you have any answer, say that answer. Keeping quiet does not make any sense. I'm waiting for your answers. I will not move ahead unless I get an answer. That is sure. Again, ask the question. What is the reading of the spring balance?
T is equals to 2F.
T is equal to 2F. So that is the reading of the spring balance. That is correct. You just have to find out what is the tension here. And we have done this before. This tension would be equal to 2F. And this 2F would be the reading of the spring balance. This is exactly correct. So that is the answer that we were looking at. Well done. That is the answer. Now let us move on to the last topic of this particular chapter, and that is known as the frame of reference. And we will just do it in very short because this is of not much importance for you guys. Now, what is a frame of reference? We are observing all these motions from somewhere, maybe from a bus, maybe from ground, maybe from airplane, maybe from a moving car. That place where you are and watching the motion is known as a frame of reference. Do we understand this? Now, every frame of reference, you will have a coordinate system, an X, a Y, and Z. So with that frame of reference, you will have a coordinate system. And according to that coordinate system, you can understand where the particle is. Do we understand this? Yes or no? So everything is with respect to a frame of reference. A frame of reference is nothing but the place from where the object, from where the observer is observing the motion. Do we understand this? We had seen relative motion. In relative motion, we had seen the motion of a body with respect to the other body. So your frame of reference becomes the other body. Sometimes we are watching the motion from Earth. The frame of reference becomes Earth. So what is the frame of reference? Just write it in short in your own language, may not be English. The frame from where the observer watches the motion is known as your frame of reference. Short, very short. Every frame of reference is associated with a coordinate system, because if there is no coordinate system, how are you going? How are you going to understand the motion if there is no frame of reference? I hope this is clear to everyone. Yes or no? Well, whenever we talk about these frames of reference, we must understand that these frame of reference are of two types. The first type is known as inertial frame of reference, and the second type, the green type, is known as the non-inertial reference frame. So there are inertial reference frame, and then there are non-inertial reference frame. Two types of reference frame, my dear friends. Inertial reference frame and non-inertial reference frame. I give you 2 minutes to write up till here, then we will move forward. Let me know once you are done, bacha. Frame of reference. Don't get bamboozled. Don't feel frightened. Frame of reference is nothing new. We have been using them. When we were doing relative motion, we were studying motion from someone else's frame. Motion of A with respect to B, velocity of A with respect to B, acceleration of A with respect to B. Those were frame of reference. Nothing else, nothing new, nothing extraordinary. I hope everyone understand this. 1 minute. Let me know once you are done. Again, you don't have to write every single word that is there on the board. Just write enough to make you understand. If English is not the language which helps you understand, write it in your own language. Have you written it? I've seen this habit of students that they write everything that is there on the whiteboard in the same language, same word. If there is, you will write is, you will not say are. Don't do that. That does not help. Understand and write it in your own language. Have you written this? Then the first type of reference frame is known as an inertial reference frame. Up till now, whatever we were doing it from inertial reference frame. Inertial reference frame. Inertial RF. Inertial reference frame. Now, how do we define inertial reference frame? So, any frame which is at rest or moving with a uniform velocity along a straight line, uniform velocity is always along a straight line, is called an inertial reference frame. Remember, this definition of inertial reference frame is a bit dicey. In fact, if we talk, there is no frame in this universe which is inertial. But for all practical purposes, we can take Earth as an inertial reference frame. So anything which is at rest or moving with a uniform velocity, you can write here with respect to Earth. Earth is taken as an inertial reference frame. Do we understand this? Earth is taken as an inertial reference frame. We will note this down. Anything which is at rest or moving with a uniform velocity with respect to Earth would be taken as an inertial reference frame. Now remember, whatever Newton laws we have read up till now, F is equal to ma and all those things, they're only valid in a inertial reference frame. Newton laws of motion are only valid in inertial reference frame. That is what you must remember. You might get an objective on that, and that is the only reason I'm telling you all this. Newton laws of motion are valid only in inertial frames. This inertial frame are also known as non-accelerated frames or Newtonian frame because Newton laws are valid, or Galilean frame. These are the three names they might ask you as an objective question. I hope I am making sense and I am not talking nonsense. Inertial reference frame. Okay. Now remember, the first line is important. And what does the first line say? The first line of this next point says, ideally, no inertial frame exists in the universe. This is the only point that you need to write. Rest is all explanation of this point. No inertial frame actually exists in the universe. But for anything that is happening on Earth, if you are taking any motion on Earth can be taken as an inertial reference frame. Do we understand this? Whatever questions we have done, these motions were happening on Earth, and Earth was taken as the initial reference frame. Now, if you want to observe the motion of planet Earth, other planets, Moon, remember Earth is also rotating, Earth is also moving, so Earth is also not an inertial reference frame. For this purpose, Sun can be taken as an inertial frame. If you want to study the motion of Sun is also rotating. You can take the center of the galaxy Milky Way at the center of the as the inertial frame. If you want to study the motion of center of the galaxy Milky Way, you can take the center of the universe as the inertial reference frame. Even that is not that is expanding. So there is no inertial frame which is inertial, but for our understanding, Earth is an inertial reference frame. So anything at rest, I am at rest with respect to Earth. I am an inertial reference frame. If I am moving with a constant velocity, if a bus is moving with a constant velocity, a train is moving with a constant velocity, that is also an inertial reference frame. Do we understand this? And you must understand 2 points, that Newton laws of motion are only valid in inertial reference frame. So 2 things you must understand. Any frame which is at rest or moving with uniform velocity is inertial reference frame. Newton laws are only valid in inertial reference frame. Do we understand this? Yes or no? Huh? I'll give you 2 minutes to
Yes,
note
sir.
this down. Let me know once you are done, bacha. Have you noted it down, bacha? Then, if one type of reference frame is known as inertial reference frame, the other type of reference frame will be known as non-inertial reference frame. The second type of reference frame is known as non-inertial reference frame. And how will I define non-inertial reference frame? One word you have to use: accelerated frame. If any frame is accelerated with respect to Earth, I'm in a bus and I'm accelerating. I mean, the bus is accelerating. So that becomes a non-inertial reference frame. Newton laws are only valid in inertial reference frame. That means you do the opposite of this. Newton laws are not applicable in non-inertial reference frame. You cannot apply Newton law in a non-inertial reference frame. Oh, that is the problem. That is the main problem. With a non-inertial reference frame, Newton laws are not valid. Newton laws are not valid in a non-inertial reference frame. Have you written this? Now, to make Newton laws valid, or to make the equations of motion from a non-inertial reference frame. Remember, Newton laws are not valid there. So if you want to make the equations from a non-inertial frame, an extra force, an extra force, oops, wrong color. An extra force is applied. An extra force is applied. This force is known as, anyone heard this name? What is this force is known as? This force is known as pseudo force. This force is known as pseudo force. So, if you wish to write equations of motion from a non-inertial reference frame, you'll have to apply an extra force, which is known as pseudo force. We'll just write what is a pseudo force. What is a pseudo force? Pseudo force, it's a fictitious force. You understand the meaning of fictitious? You see cinema, you watch serial. Fictitious means does not exist. Imaginary. It is an imaginary force, non-real force. It does not exist. It's an imaginary or a non-real force. It does not exist. It's like a writer. I'm a writer and I start writing something. I start writing a story, Star Wars, Avatar 2, Avatar 1. All these are fictitious stories, imaginary stories, stories that exist in our head. Similarly, pseudo force is a fictitious or imaginary or non-real force. It's applied only if equations are made from where? You only need to apply pseudo force when the equations are made from where? Huh? From non-inertial reference frame. You only need to apply pseudo force when you make the equation from non-inertial. Oops, wrong color. Do we understand this? From non-inertial reference frame. Yes or no? Now, what is the value of this pseudo force? So write the magnitude of pseudo force. Magnitude of pseudo force is equal to m into a. What is m? M is the mass of the object. And what is a? A is not the acceleration of the object. A is the acceleration of your non-inertial frame. Do we understand this? Do we understand this? Yes or no? This has gone above or at saying bye-bye. I'm going, don't worry about me. So the magnitude of pseudo force is m into a, where m is the mass of the object and a is the acceleration of the object. Then the next question would come, what is the direction of pseudo force? Direction of PF. PF means pseudo force. What is the direction of pseudo force? Yes, my dear friends. Direction of pseudo force is opposite to the direction of A. What is this A? This A is again your acceleration of the non-inertial frame. Do we understand this? Yes or no? No, yes. Huh?
Yes, sir.
For example, I'll give you a quick example. We'll do questions of the pseudo frame in the next class and we'll finish the Newton laws of motion in the next class. If I give you a quick example, this is what? This is not a dabba. This is a lift. This lift is moving up with an acceleration A. This lift is moving up with an acceleration A. Now, if there is a block hanging in this lift and I am inside the lift, so now I am inside the accelerated frame. Do we understand this? Now, if I draw the free body diagram of this block, one would be T, the real force. One would be mg, the real force. But now since I am on an accelerated frame, I will have to apply one more imaginary force. What will be the direction of that imaginary force on this body? Lift is moving upward. So what is the direction of pseudo force? Lift is moving upwards. What is the direction of pseudo force?
Downwards.
Downwards. So I will have to apply this downwards. What will be the magnitude of this pseudo force? Mass of the body multiplied by acceleration. Do we understand this? So this blue gentleman is your pseudo force. Do we understand this? And it needs to be applied just because I am making the equations from a non-inertial frame. Do we understand this? Okay, that's it, and we will end this class here. So I'll see you in the next class, where we would be finishing this chapter and moving ahead with friction from your Monday onwards. Take care. Have a nice day. God bless you all. Bye-bye.